And then there is a 10 URL. That's the link to our Deep Note workbook, which is what we're going to be going through for this workshop. So yeah, just sign in and then make a duplicate of the workbook. That was me. That was you? Okay. Oh, that's so loud, Bill. I'm sorry. Oh my gosh. Not at all. That's crazy. Anyway, we start. Yeah. Okay, guys, we're just gonna get started. So, welcome to our Intro to SQL workshop. In case you haven't heard of us, we're Data at UCI. So, yeah, so Data at UCI, we are a community of anteaters hoping to explore the world of data and our place in it. So, we host a variety of events, including things like technical workshops, networking, and our annual datathon, which is like hackathon, but for like data science. So for this workshop, we're going to be going over first just the background of what SQL is, what are relational databases, and then we're going to go into the basics of some SQL queries. So starting with the background. So databases are collections of data, shock, but there are basically two main formats that we see databases taking. The first one's known as a relational database, which is what SQL is used for, and the second is known as a non-relational database. If you're interested in non-relational databases, Google MongoMD or MongoDB, some stuff will show up. But an example of something that we would use something like a relational database for is an e-commerce shop. And for this workshop, that's what we're going to kind of be using as an example. So using relational databases, you can track things like transactions, customer information, and consumer behavior. So getting more into what SQL is, you've been hearing me pronounce it, but it's SQL as in the sequel to a movie, but it stands for Structured Query Language. So a query is basically just like a set of like code or whatever that tells like SQL what you want it to do. So if you look on the left, you can see there's a table, and then underneath it, there's like this block, and that block is what's known as a query. And to kind of get a little bit into what a relational database is, basically you have a database, you have a bunch of tables, and SQL says, okay, this table is related to this other table in this specific way. This table is related to this other table in this specific way. So basically, a relational database is a bunch of tables with very specific relationships that kind of govern how your data can be inputted and how it can be extracted. Yeah, and some questions we can answer using SQL are questions like, which product had the highest sale in January, which, as you can imagine, for a lot of things like, in your guys' case, building websites can be very useful if you're just trying to answer some basic questions, but we won't get into it in this workshop. SQL can answer some very complicated questions when you get like really into it. So for this workshop, the example we're going to be going through is our made-up storefront called Sunburst Clothing. So shockingly, we are indeed a clothing store, and in this example, we get a bunch of shipments of new products, and then we also have a bunch of orders. We have limited time discounts. We get new members every month, etc. I'm going to give you 10 seconds. If you have not already gotten the Deep Note workbook, we also have linked it in the Slack workshop channel, but this is the 10 URL. So 10 URL / VenusHacks intro to SQL. Hopefully you guys got that. So just getting to some of the basics. First, this is the setup for our workshops like mock database. So this is also included at the very top of the workbook if you ever need to reference back to it. But basically we have 5 tables and they all have a bunch of different like information in them. And then you can see in some of these tables you have like matching columns. So if you look here, we have product ID in the order table, and then we have product ID in the product table, and then product ID in the shipment table. And as you'll see later, it's through these matching columns that SQL is able to like relate different tables to each other. And we're able to like write our queries basically. So, okay. Elaine's gonna take over.
Okay, perfect. So now we can move on to some SQL basics. So every SQL query will have 2 words, select and from. So you select the columns from the specific table that you're working with. So let's take a look at an example right here. So we have this query, it says select name, comma price from product CSV P. So, sorry. So we see the first step here is from product. Product is the table that we're working with. And the P in the end is optional. We don't need it, but it's just the name for the table. And what we're doing here is we're selecting the name and the price. This is just a very basic implementation of how you can use a SQL query. Yeah, so this says, give me their names and prices. Here's another example that says, select everything. So the asterisk right there, that represents everything in the table that you're working with. In this case, the table that we're working with is discount. And again, we've given it the name D. That is optional. Please no, you don't need it. But here we're saying, hey, SQL, from the discount table, can you please give us everything that's within the table? And now we can move on to something called data filtration. So this is where you want to actually filter through your data, where you want specific clauses and conditions to be met. So if you take a look at this SQL query right here, we have select column 1, comma 2 from table name, and where we have a couple conditions. And between the conditions, we have word operators. So if you look at the table below, you can see comparison operators and word operators. So obviously the comparison operators are like are less than, greater than, equals to. For not equals to, we have that specific one. I know a lot of you are used to the exclamation point equals, but this is different in SQL. Kind of rhyme. Okay, and then we have the word operators, obviously, and, or, not, in. And in this case, we're using and. So here are a couple of examples of how to actually use this. So we have 5 is greater than 4. It's a Boolean expression. I think we all know what this is going to give. 5 equal to 5, true. And then we have here using the word operators, right? So saying 5 greater than 4 and 5 equal to 5. And that's just another Boolean expression. Here we're using more of the word operators. So we have 5 in 1, 2, 3, the tuple 1, 2, 3. And obviously 5 is not in this tuple, so we will get the answer false. And the next one says 5 not in 1, 2, 3. 5 is indeed not in 1, 2, 3. So this would give us true. And for the next one, 5 is equal to the tuple 5. This will actually give you true. Yeah, this will actually give you a true value. So here are a couple more emails. So the prompt that we're trying to look at is look up the emails of the members who joined right after June. So here we see we have a couple clauses, right? We're using the member.csv table, and we've given it a name M, and we're selecting the email, but we have a condition where the join month column has to, the data of the join month column has to be greater than the specific date. And in this case, we're saying it's greater than June 1st, so right after June. Yeah, so this would give you all of the emails of members. Does anyone have questions? Yes. Between.
Yes.
Yeah, it just depends on the data that you're like from the table that you're working with, but everything's like it works.
Yeah, so you can use like for dates, you can just say like, okay,
Less
is the date greater than, and then the string of the date, as long as it's in like the same format where it's like, I think this one we had was like year and then hyphen. Yeah,
It
Yeah.
will work.
it'll work.
If you guys have taken 33 with Thornton, if you remember project 2, that was like basically this, right? Like I don't know how many people took 33, but that was like one of the easier projects because SQL is very like user interactive. It's very adaptable. Also, you should know it. It's on the final, FYI. Okay, moving on. Here's another example, but this time we're changing it. We're adding 2 columns that we're selecting from, right? First name, last name. And then this time we're doing 2 conditionals as well. We're using the and word operator, and we're saying join month greater than a specific date and join month less than a specific date. So this will give you that like intersection or like right between those dates. So we're saying look up the names of members who joined in June and July. Okay, so here's another one. We're using the asterisk. So can anyone tell me what the asterisk means if you remember? It's like blurted out. Yes, everything. If we had candy, we would give it to you. But we don't. So this has select everything from order, the table order, where the prod ID is in the tuple 1 or 3. So basically, if you look in the bottom, we see that the prompt is find all the UC Irvine crop tops and women's biker shorts. So the prod ID in this case, like you can say crop top is 1 and women's biker shorts is 3. So if you wanted to look at something like that, you can use like that tuple and like, you can use the operator. Yes.
Is the order.csv optional and O is the actual
No, order.csv is the actual thing that you're taking from. O is optional. O is just a name for order.csv. So you'll see later on we'll use the actual name within the queries and then later examples. But for what we're doing right now, we're not specifically using O. We're just using order. Yeah. Okay, let's look at null values. So similarly, we have null values. So value in null, that will return null. 5 equal to null, that's going to return null. And value is null, it's going to be true or false depending on what value is, right? If value is actually set to equal null, it's going to return false. True. And if value is, not null, then it will return.
Just a quick aside, guys. So null values are probably going to be like the thorn in your side when you're trying to work with SQL because they're everywhere in almost any database. You just have missing information. And so we'll get into a bit more of this later, but you do have to be very aware of how null values can interact with your queries. So in this example, we went through some cases in which the value returned is null. That is significant because if you have a query that has a null being returned, you'll basically get no rows returned. So yeah, just keep track of that. We'll go into a bit of depth, but honestly, I suggest that if you're implementing something in SQL, if you have any questions, just Google how do nulls interact with I don't know, this part of SQL, and yeah, sorry.
Did you have a question? Yes. No, for the syntax?
No.
Just kidding, no.
It might depend on there are different implementations of SQL, but the ones I've worked in, it usually doesn't matter.
I think it's not.
Yeah.
It might depend on the IDE as well that you're using. Okay, here we have another example using null. This time we're taking a look at discount codes that are not null from the order table that we were working with, and we're selecting order ID. So obviously we want to make sure we're asking SQL from the order table where where there is not a discount code implemented to get that order ID. No, there is not a discount.
No, discount code is not null, so it exists.
Yeah.
Okay.
Sorry. And here's an example of a bad query. So the point is we want to return all the orders from non-members. So we're selecting all, right? We're using the asterisk, so we want all of them. We're using the order table, and we're saying where discount code is equal to null. That is not valid syntax. Your IDE will say, what are you doing, dude? That doesn't make sense. So you can use, again, like we did here, is not, or is, or in, or is, or yeah, like that, is null instead of equals to. Okay, now actually before that, does anyone have any further questions on the basics of SQL? Okay, cool. If you want to, we have a practice problem. You get about 5 minutes to do this. So the point is we want to return the order ID that contain the July promo code. The promo code is given right there. It's 2065 and are from members only. So here's a hint, use the order table, and you can refer back to the previous where examples. Yes. Oh, and you guys should have access to this one. So we'll leave you about 5 minutes. No, just do it. Just no, just no, do not. That's what happened. Yeah. I will start at like 20 or right after the speech. Or Z. Or Z. Did you have other words to
Not just that.
we did look at design?
Oh, do you?
Yeah.
Oh, yeah, we had to, Wix.
Oh, yeah.
Just
Yeah.
crazy. I don't know, it's so mom did.
No, she uses WhatsApp.
She does.
I have something.
She uses WhatsApp, that's so crazy.
I have look at my list and then
That's really important.
I keep my WhatsApp on charge.
Oh, I still have it. Well, I have like, my mom's have to have.
Oh, really?
They didn't want like pay for international text messages.
Yeah, yeah.
Like use Line.
That makes sense. And then, like I have like
Really? I asked them for free.
and they all use chat. I'm like not chat. Okay, should we start? Yeah. Okay, so let's start going over the solutions for this very not complicated problem. So this is not the only solution, by the way. There's obviously a million different ways to implement this. But basically what we did from the order table, we selected order ID column and we gave the condition that where the discount code was equal to 2605, which is the July promo code. And we said that member email is not null. Obviously, if member email is null, then that person has not provided us a member email. Or email to be put into our database, therefore they are not a member, right? So this will return the all the order IDs that contain the July promo code. I'll give you guys a second to look at that and then we'll move on to the next topic. Does anyone have any questions? Anyone struggle to get the solution? Oh, okay, that's okay.
Okay, now we're gonna go on to the next part of our workshop, which is joining tables. So obviously, like I said earlier, relational databases basically made up a bunch of tables. And because of that, joining tables is a very crucial part of knowing how to like write in SQL. So we're gonna go over in depth just one of the joins called the inner join. So to give a broad overview, basically you have two tables and you wanna join where those tables overlap. So we'll get more into it in a second. But basically, we have this query. And we have the same things we saw before with select and from. And then what we're adding is two new clauses. The first one is called inner join from. And we also have another clause called on, and that says we want to join where these two columns from our first and second table are matching. So it'll make more sense in a second. Okay. And what we can think of those as is basically we're saying get the table order and then product. Then what we're saying is we want to join on product ID from table order and from table product. So what that's saying is, okay, I want to look at the order product ID and I want to look at the product ID. And then I want to join where these two are matching. So if we look at order, we see that there's the product ID 1, 2, 1, and 4. And then in product, we have IDs 1, 2, and 3. And we can see that the only product IDs that are shared between the tables are actually 1 and 2. And then in order, we also have this product ID 4, but that's not in this other table. And then in the product table, we have the product ID 3, but that's not in the order table. So what this type of join will do is it will drop these columns that don't have a matching product ID from the other table. And then it will join together the remaining rows. Does that make sense? Because that was a lot to throw at you guys. Are there any clarifying questions? Okay. Yeah, so it actually does this. So it takes those instances in which we had matching product IDs and it lines up like the rows together based on that product ID. And so now we have all the attributes from order and all the attributes from product, but some of those rows have been dropped. Any questions? Yes. Mhm.
But for this table, can we set it into variables where we can create like, or does it only exist in
Generally, you don't really like save tables in SQL, but you can use like a subquery. So we'll get into that a bit more later if that answers your question. Okay. So the last part of this is just when we do select sold name or sold date and name, you're just taking from that new table the sold date and the name. Okay, yeah. So as you can see, there are a bunch of different types of joins. We just did the inner join, but there are other joins, the most common other one being called the left join, and then there's also the full join and right join. The differences between these joins are basically, in our inner join, we said that in order for a row to be included, the product ID had to be in both like the order table and the product table. For other joins, you might say, I want all of the rows from the order table and any matching rows from the product table, but if product like doesn't match, I still want to keep all of the rows in order. And then you can also flip that. So if you guys do want to implement SQL, I would suggest looking more into left join, but it functions in a pretty similar fashion. Are there any questions before I go on? Yes. The what? Oh, okay, yeah. So what this is saying is for our inner join, you know how we said that it had to be in both like the first table and the second table? Because of that, we only want the rows in which there is an overlapping product ID. And then if we look at the full join, because like everything's highlighted, that means that we want the rows that either have a product ID in the left table or the first table and a product ID in the right table. So what that'll, sorry, yeah. I don't know if it's like an efficiency thing in terms of what will drop the most, like inner join will drop the most and then full join will drop the least. It really depends on like, it depends on like the specific problem you're working on. Because let's say, I'm giving a quick example. Okay, in this case, like I have all my orders. So then maybe I have another table that's like kind of half filled out. So like maybe some people gave extra information on like their address, right? So let's say that I want all the orders and then like if they have the address, then I'll add it. But if they don't, I'll just leave it blank. Then I would use something like left join because what I really care about is keeping all the orders and then I'll add on any extra information in terms of like address. So because of that, like I'm keeping everything in the left table or the first table and adding on whatever's in the right table if they have it. That's why like in the left join diagram, this entire thing for table 1 is highlighted and what's overlapping for the both tables is highlighted, but whatever's like in the second table but not in the first is just not highlighted because basically I'm saying if it's not in the second table, but it's in the first table, I'll just leave it blank. I don't care. Does that make any sense? Any clarifying questions? Because this is an important topic. Yes. Yeah, that's the only difference. Any other questions? Yes. So if you export it as like a CSV file, you can then import it into like a SQL, I'll call it IDE. There are like just several things you can download. I use like MySQL. And then if you like import it as a table, so you don't have to like define how you want the table to be set up, but if you do, then you can just run SQL queries on everything. So I don't know if you had like every class that's offered and then like what professors are teaching what classes, and you just had like all these tables that like were describing like all the courses, and you had like a very specific question like how many courses were taught by this professor in this year, or like how many students took this course, blah blah blah, or whatever complicated question you want to ask, you could use SQL for that. Yeah. Any other questions? Okay. So the next thing we're going to go into is limit and order by. Okay. So these are some very common clauses also used in SQL, because a lot of the times, a lot of our most basic questions are like, what's the top whatever, or what's the fewest blah. So that's kind of when we use order, and then limit is just saying like, limit it to like the top 5 or the top 2, something like that. So in order by, we just say like order by, and then we say the column that we want to order by, and then we specify ascending or descending. This will make more sense in a second. And then limit, we just say like, we want to limit it to 2 or 5. It'll make more sense when you see an example. So the example we have here is we're trying to find the name and the price of the 2 most expensive products. So first we're saying, okay, SQL, get the product table. And then we're saying, okay, I want to order by price. So I want to order all my rows based on the price in that row. And then I'm going to order it by descending so that the highest prices are at the top, and then it goes down in price as you go further down. And then I'm going to limit it like the entire output to the top 2. So it will only give me like those top 2 rows. And then finally, I'm selecting the name and the price from those rows. So in this way, I can get the name and the price of the 2 most expensive products. Any questions about how order by or limit works? Oh, no, yeah. Mhm. Okay, no worries. Okay, yeah. So the next question we're gonna go into is, we want you guys to return the product IDs of the 10 most recent orders. So the hint is use order by and limit and use the order table. I'm gonna actually add in an additional hint because it is kind of confusing. You're gonna be using the date column for this, and think of a date as just, imagine it like it's an integer that says how many seconds have passed since like 0 BC or something. So like if the date is like longer ago, it'll be a smaller number, and if it's more recent, it'll be a bigger number. That should help you when you're deciding like order by descending or ascending. So yeah, we'll give you guys a few minutes for that. If you wanted to go to Disneyland, but you want to pick this one. Oh, so it's like, it's where that. It's like, you know, Yorba Linda. Yeah, it's like right next to it. No, okay, it's like right on the edge. Like if you kept going north, it would be like further inland. Yeah, I'm not even sure. Oh my gosh, she knows. Okay, you know when you cut through the canyon? Yeah. Yeah, so I'm the last house, like the last neighborhood before you enter. Yeah.
Oh, I
guys. You're like, honestly, no, my mom, every time we get it from school, she would like enlisted you to get there as fast as possible. She's like, it's gonna be so bad. No. Gosh, downtown LA. I didn't even know people live there who were like single. Like, nobody lived there. Like once. I've been to the Canadian one time. Are you good there? I don't go in. I go. My board can get better. Not exact. Oh yeah, there's a ring. Well, that's supposed to be. I think anything else you can do. Is it? You want to start? No, start with or 30. Yeah, I'm start. I just have my stupid picture on all my photos. If you get about it. Okay, guys, hopefully you had a chance to at least start approaching the question, but we're gonna go over the solutions because we do have limited time. So, okay, here is the solution, not the only solution, just the solution that we came up with. So, going through the order table, and then what we want to do is we want to order by the date that the item was sold, and we're gonna sort this in descending. So remember, we want, where is it? The 10 most recent orders. So more recent times will have a larger date value. And so we want the largest dates at the top, and then we want them to get smaller as they go down. So because of that, we're going to sort by descending. And then we said we want the top 10, so we're going to limit it to 10. And then we want the product ID. So are there any questions about this query before we go on to the next section? Okay. So Elaine's going to take it away and discuss aggregates.
Okay, so aggregates are functions that do calculations and return a singular value. So here we have a couple of the most common ones that you'll probably be using. We have count, count all, and then count column. We have sum column, average column, min and max, and then we have distinct. I think most of these are very it's common sense to understand what they do. But distinct is something that returns the unique values in a column, including null. So this would be useful if you want to check what values you have within the column that you're working on. So here we have an example, and we're going to be calculating the total number of orders with missing emails. Therefore, this is a case where we can use the is null word operator. And so we're doing select count all, we're counting all the elements in order, CSV, using O as the name of the table, and we're saying on member email is null. So that's for our values where member email is actually null. Any questions? Actually, any questions on what the concept of aggregates are? These are just built-in functions that you can use. Okay, cool. So here we have another example using distinct. So from the order table, we're going to be getting the sold date where the date is specifically June 10th. And we want all the unique member emails. Obviously, if I'm looking through like an order list, maybe someone has purchased an item twice in the same day. That's fine, but I'm looking for just how many people have purchased, and I don't want to count that same person twice. I would use distinct. It would give me every unique email within that list. Here's another example using sum. So in this case, from the order and product table. And so I think someone asked what the point of using like O and P at the end is. Here's why we use it. We're specifying from the product ID from O, from table O, and the product ID from table P, right? You can see how we're differentiating between those. So basically here, we're just calculating the total revenue, and we're connecting the tables on their product ID using inner join, which Katie just explained, and then we'll calculate the sum of all of the ordered products. Does anyone have a question on this one? Since I think using like all of them. Yeah.
Explain the on-off
Okay, so basically on is just telling like, remember when we were doing joins and then we'd say like, okay, we want these two columns to match? On is saying like which two columns we're matching. So in this case, we're trying to match the product ID column from order and the product ID column from the product table. Does that make sense?
Did it use the company with auto operator?
Yeah, you use it with like the joins. Yeah, so you can actually say like on, let's say O dot product ID equals P product ID, and then you'd say like, and this other column equals this other column. So you can have like multiple things that you're matching on. And that's actually very common because for a lot of times, like when you have a table and you're trying to like match it with another table, you might need like two unique identifiers. So let's say you're trying to match people based on their names. You'd want to match based on both the first name and the second name. So you'd say like the table one dot first is equal to table two dot first name, and table one dot last name equals table two dot last name. So yeah, great questions. Any other questions? Okay.
Here's another example, calculating just the min and the max. We're using the same column, right? Price, and we're taking it from product. Okay, and here's another practice problem, around 5 minutes for this one. We just want to know what is the price of the cheapest non-discounted product. So we're going to be using the order table and the product table. And again, we want the non-discounted product. So 5 minutes. Not really. I think this is okay. So let's go over the solution for this one. Again, we want the cheapest, so you have to consider that we're going to use min, and we're looking at the price. We're using the order table again, and we're using inner join to connect the prod IDs from table O, which is order, and table P, which is from the product .csv file. And we're checking where the discounted code on the order table, you can see that we specified O, is null. That means that it's not being used. The order code is not being used in that specific table. So this is the solution. Any questions?
Okay, next we're gonna get into probably the most complex topic that we're gonna cover today. It's what's known as a subquery. So this is like kind of the intro into more advanced, more practical SQL. Basically, a subquery, you just take a normal query and then you use it in like another part of your bigger query. So not actually that complex of an idea, but once you start implementing it, it can get a bit confusing. So, okay, here's the example we have. This is our like normal query. So we're just going to use this, and then we're going to use this query in like another part. So first, I'm just going to explain this query. We're selecting the distinct member emails from the order table, and then we want the rows where product ID is 1 and member ID is not null. So in English, we want the unique member emails for the orders of product ID 1, and then we want them to have a member email, so we want them to be a member. Okay, so this will end up kind of spitting out this smaller table. So this is the result of this query. Now what we can do is we can use the result of that query in another query. So in this bigger query, we're saying, okay, I want the first and last name from the member table where that member's like email is not in this like smaller query. So then what this is saying is I want the first and last names of the members who have not ordered product 1, or like whatever product has product ID 1. Does that make sense? Any clarifying questions? Anything you want me to go over again? Okay. So this will end up giving us like just this smaller resulting query. Okay, so this is just like, I've just rewritten like the previous example. What I wanted to highlight is we have to say member email is not null. And the reason we had to say this is because we kind of briefly touched on it earlier, but when we use distinct and then we put in a column, it will give us null if like null is in that column. So like if I have a column of member emails, I have like email 1, email 2, email 3, and then I have a null email. When it's listing out all the distinct ones, it will say like, oh, email 1, email 2, email 3. Oh, and there's null, like that's a distinct value in this column. But then the issue is when we then go to like check the condition email not in, and then we have the list and it includes null. When it tries to compare email to null, it'll like, have a meltdown, and then it'll just end up saying like, I don't know the truth value of this query because I don't know what null is. I can't check if email like is equal to null. And so it'll just end up saying the entire query returns null. So we'll just end up with no rows. So this is an example of when you have to be very careful when you're handling nulls, because if we don't include this line, like this condition member email is not null, actually what this query will end up spitting out is just nothing. So just something to keep in mind. Any questions about that at all? Anything I need to explain again? Okay, cool. Yeah. I would suggest it, yeah. I mean, if you know you don't have any nulls, you can like ignore it, but it's mostly important if you are trying to then use the result of select distinct to compare it with something else. So before when we did select distinct, we didn't check if it's not null, because like if I'm just spitting out emails and it says null as one of the emails, it's like, yeah, whatever. But then if I'm checking those emails against something else, that's when it'll start causing issues. So it's really when we're comparing null values with something else that kind of causes SQL to just like, and just stop working the way we want it to. So yeah. Does that answer your question? Any other questions before we move on? Okay, cool. So we're actually gonna go on to our very last example. So for question 4, we want to name the first 2 members. So that is the members with like the longest ago date. So that would be like the date with the smallest integer value. So name the first 2 members that purchased our item women's biker shorts. So that's going to have product ID 3. And our hint here is, okay, you're going to use a subquery because that's what we just learned. And then we would also suggest that you use the member and order table, and then also the limit and order by functions. So if you need to reference like anything about the tables, it's at the very top of the deep note notebook. And then if you want to reference like previous queries, good ideas, we'll give you about 7 minutes. So just chat with others and then you can leave questions on slide. Wait, sorry, can you repeat that? Oh, yes. So, maybe I have a slide on that. I think I got rid of the slide on that. Okay, yeah. So basically, the order is usually select, and then from, and then join, and then on, and then I think it's order by, and then limit. But if you have an issue, I would just Google what order you put it in. There. I can also pull it up. Yeah, it's like at the end of it. Oh, you moved it, okay. Okay, we also have it here. Yay. Oh yeah, that was kind of crazy. Too much. Okay, so library. And I was always back on like, how does that even what capitalism work? You don't just help people. Like I would, if I was ever writing something, I'd like our language don't work anyone else's phone yours is faster. Yeah, but then if you want to exactly. So I'm like, but then why don't people release software that would mask your value so that it doesn't move on? They do? I didn't know that. No, I know IPs and VPNs and stuff. No, I'm trying it out like when you can download onto your router so that it won't route anywhere else's, but people won't think you will. So then like they'll allow you to run through there or something like that. I don't know. Maybe it exists. I was just thinking like I'm surprised that the system works so well. It just doesn't seem like it would work. Like if someone proposed that thing, I'd be like, no, I'm not gonna route their data. Yeah. Like I remember I used to think I was misunderstanding. Oh no, I must be getting wrong ass. Like drops then I'll wait like yeah, I'm just like I'm driving like this. Yeah, they're supposed to like sense it. Okay, we're just gonna start going over the solution. So obviously, nice and complicated subquery. To just kind of reiterate the question first, we wanted to name the first two members that purchased our product women's biker shorts. So that's product ID 3. So the first thing that we want to do is we want to say, okay, from my member table, and then we want to have a subquery that says, okay, where the member was one of the first two people to order biker shorts. So to kind of break down the subquery, what we're saying is we're looking at the order table, and we want the member email to not be null. So as we stated before, if the member email is null, it'll cause issues. And then we also want to add the other condition. We want the product ID to be 3 because we want to only look at orders for the women's biker shorts. And then what we also want to do is we want to order by the sold date in ascending order. So what that will do is it will give us the earliest orders at the top and then later orders as we get further down. And then we want to limit it to the top 2 of those orders. So that will give us the first 2 orders for the women's biker shorts, and the emails of the first 2 people to order the biker shorts. And then if like the email is in that list, then we want to get that member's first and last name. That was a lot. Any questions about this query or just about anything that we've gone over so far? Because this is our last slide. So if you have any SQL questions, now's the time. And we just did that good of a workshop. That's crazy. Also to reiterate, this is not the only solution. There's always like a million different solutions to SQL queries. So be as creative as you want. It might make your life harder though, but whatever. Anyways, okay, yeah, that actually wraps up our workshop. Thank you guys so much for attending. If you want to learn more about data UCI and some of the other workshops we host, Linktree, we have a link to our Discord, website, newsletter, LinkedIn, I think, a million things. But thank you guys so much for attending. If you have any more SQL questions, you can come up and ask us. Oh, okay.
Why is this for me?
Oh, you're still on the wrong one.
Oh, you have it this
I
way?
know. I think you're weird.
So
Also,
If you,
oh, go ahead.
if you guys haven't signed in, can you please sign in? It's for
if you want a prize, sign in.
Shares a really good.
Yeah.
I don't know what it is, but
It's gonna be.
they're hacked. They got monies. Yeah.
Thank you for presentation. I have
Yeah.
two questions.
Yeah.
First, as for the last,
Mhm.
the last question, is this solution valid? I'm trying to think, like where I can.
yeah.
Kind of
Can I
think-
see?
Oh, yeah, sure.
Can you pull up the question again? Actually, I'll just pull it up. Can you pull it up this? Okay, select member from member.csv, interjoin order.csv, on the I think that should work. The only thing I could think of is, oh, so you have to say the member's email. So if you just said like select member, so I think that might be where the issue is coming up. Because like there's no column called members, so you have to say like I want m.email or m.member email like we have here.
Yeah.
That makes sense?
Yeah.
So your first thing you select is I think that might be so can you try choosing that one?
Oh, no, it's not very working with the thing. terminology.
Oh, okay, okay.
But swapping out that with like first and last, and that should be a valid. Okay.
Like, can you answer?
Yeah, do you
Give me a second, I'm like trying to remember how.
So I have this scheme right here that I kind of made slash like copied from a public database. What I'm trying to do is create this table called user, right?
Right.
But my question is if I could add multiple values into the column.
You should be able to. Is it giving you an error?
I haven't tried it yet because I want to know like, what I could do right now. Like I want to like right here with his favorite countries, I'm gonna add like country IDs. So
You can. You should be able to. Let me.
Okay, yeah,
You didn't know.
I actually don't know. I don't know why I feel like I have to do that. But I'm trying to find a use case where like, using
Force?
sub query is
Okay.
more convenient and also
Yeah.
like
Never
into the
mind,
thick
fine.
of necessary.
Yeah, so.
I think it should work if you can like run it. So how many more are you trying to like do? You said favorite countries and then what?
So like, no, just like
Okay,
favorite
table
countries in
gets
general,
ready
so like,
So
um,
like, let's say.
basically in that row, that
some of the
specific
questions
column,
that
like,
you
my
might
user's
ask
gonna have
in
like
SQL are
multiple
like.
countries that they.
there was,
That
like,
they
a
want?
statement
Yeah,
that
well,
was, like, my
if
students
it's like a
and they
string,
wanted us to
right?
ask,
If it's like, okay,
okay,
so you have user one,
want
and then
all
user one
instances
in,
which these two
they have
were,
like an
like,
email, they
thinking
have a
about the
password, they have
same
a name,
topic,
and then they have favorite
but
countries. So
with
in
the
favorite
tables not
countries, it would be like Spain,
in
comma,
those cases,
whatever,
you kind
comma,
of need
comma,
to make
comma, right?
summaries
So
for,
that would
like,
all be considered
let's
one
say first
item.
sentence was, like, all the topics
Yeah,
we read for
in
today, and second
SQL.
was all the
So do you
topics we
suggest I
read
just make it into a string?
I think that would be much better. If you want like the number, so I see you put integers, right? Favorite countries integer. That means you're telling that it's gonna be an integer. So then it would just be like 5, 6, whatever, right? But if you want to actually specifically see what's in it, so if you want like, okay, I want to see it, then maybe making it like some sort of string or a text like yeah. And then you can say not null like you have here below. I don't know if you know what that like when you say not null, that means it can't like you can't
have like
you can't give it a
Can't be-
null
can't be-
exactly. Yeah, when you make it, you can't say that. Okay, I'm gonna set the null. But yeah, that should work.
So just turn it into a string.
Yeah, if you want to see specifically what's actually in it instead of a number.
Expect people to
Yeah.
know how to do that after. But if you're interested, I would take CS 1.2A.
Oh my god, but CS 122A is they're not opening the second section because they don't know who's gonna teach it.
Oh, because of the first.
Really?
Yeah.
My professor, I think, I heard he was like bad.
He
Yeah.
was so bad that they're probably gonna
My
fire him.
professor.
So the first section's like already filled. Did you already have your registration?
My enrollment?
Yeah, yeah,
I'm
yeah.
not taking it next.
Or
No, I take it. 122A.
Yeah, 1.2A.
oh, you already took it?
Oh, yeah.
Got it.
Oh,
Yeah,
you
yeah,
got
that's
it.
what
Oh, okay, okay.
Yeah, yeah.
I
so
tried
it's-
signing up for it and they said like it's closed.
Oh,
because-
yeah, I had a friend who had that.
Yeah.
So hopefully you guys will get it, you'll get a better professor.
You
But
probably
it's a
will.
pretty good class in terms of like, it does teach you SQL. Our guy didn't teach it to us, but you are expected to learn it, so you'll learn more about it. Any other questions? Seth?
Yeah, second one is